People think I only burn, but I protect.
I guess you never forget the smell, especially mine.
I don't stay though. I just taste the pain.
So let's begin with something simple. For those watching, could you introduce yourself? Who are you in the world of organic chemistry?
Certainly I'm phenol, an organic compound where a hydroxyl group, what you may call a negative OH group, is directly bonded to aromatic benzene ring. That connections give me unique characteristics that set me apart from alcohols. While alcohols have the negative OH attached to unsaturated carbon, mine is attached to an aromatic ring, making me far more reactive.
So, structurally speaking, how does that bond affect you?
That bonds make me acidic more than alcohols but less than carboxylic acids. It's because my aromatic ring stabilizes the negative charge that appears when I lose a hydrogen ion from my hydroxyl group. In chemistry, we call that resonance stabilization. I appear as a colorless crystalline solids at room temperature and have a distinct, somewhat medicinal odor. However, I can be toxic and must be handled with care as I can irritate skin and eyes.
And where exactly can people find you in real life?
I may not be visible, but I'm everywhere in human life. I was once the basis of antiseptics and disinfectants, like the historic use of carbolic acid by Joseph Lester in the 19th century for sterilizing surgical instruments. Today, I play a key role in producing plastics, resins, and pharmaceuticals.
So it sounds like you have both beneficial and harmful sides.
That's true. In low concentrations, I help heal and preserve, but in higher amounts, I can burn, corrode, and poison. It's a matter of balance of how well humans handle and respect my power.
If there's one thing you'd like people to understand about you, what would it be?
That chemistry isn't about good or bad. It's about purpose. In the right hands, I can protect life. In the wrong ones, I can harm it. I'm not dangerous by nature. I'm just reactive by design.
Let's start with who you are. Could you introduce yourself to our viewers?
Of course, I'm thiol, also known as a mercaptan. Structurally, I'm an organic compound that contains a sulfhydryl group, written as negative SH, attached to a carbon atom. You could say I'm sulfur version of an alcohol, similar in form but with sulfur replacing oxygen.
So, what makes you stand out from the others, chemically speaking?
My smell, no question about it. Most thiols have strong, pungent odors, often compared to rotten eggs, garlic, or skunk spray. That's because sulfur atoms release volatile compounds that our noses detect even in tiny concentration. In structure, I'm less polar than alcohols because sulfur is larger and less electronegative than oxygen. That means I form weaker hydrogen bonds, giving me lower boiling points than alcohols with the same molecular size.
So, aside from your smell, where can we find you in the real world?
Oh, I'm useful. Even people turn away from me. I'm added in natural gas as a safety measures that sharp smell warns human in leaks before danger strikes. Without me, natural gas, which is odorless, could fill a room unnoticed. I also appear in proteins, especially in amino acid cysteine, where I help form disulfide bonds that give proteins their shape and stability. Some of my derivatives are even used in medicines and methyl recovery because sulfur bonds tightly with heavy metals. In a way, I detoxify, I bind what's harmful and remove it.
But like phenol, you also seem dangerous if misused.
That's right. In concentrated form, I can be toxic and cause irritation. And because of my volatility, I spread fast. Even a small spill can feel alive with my scent. But I don't mean harm. That's just sulfur's nature. Bold, reactive, impossible to ignore.
If you could describe your purpose in one line, what would it be?
It's to warm, to connect, to remind humans that even the foulest scent can serve a vital purpose.
So, for those watching, could you introduce yourself?
I'm ether, an organic compound where an oxygen atom is connected to two alkyl or aryl groups. My general formula is ROR. You could say I'm the bridge, oxygen linking two carbon groups.
That's actually a beautiful way to put it, a bridge. So, structurally speaking, how does that affect what you can do?
Because my oxygen sits between two carbons, I am quite stable and unreactive compared to alcohols or phenols. I don't form hydrogen bonds with myself, which makes me less polar and give me lower boiling point. But I can form weak bonds with water, which is why some of my smaller forms dissolve slightly. At room temperature, I am highly volatile and I evaporate easily and mix well with many organic substances. That's why I've been long used as a solvent in laboratory and industry.
Where might we encounter you in the real world?
Historically, I was famous for my role in medicine. I served as one of the first general anesthetics, allowing patients to sleep peacefully through surgery. Although modern anesthetics have replaced me, I marked the beginning of pain-free surgery, a milestone in medical history. Today, I'm widely used as an industrial solvent in the production of plastics, perfume, fuels, and waxes. Some of my derivatives, like diethyl ethers, are also used in laboratory extractions and chemical synthesis.
You sound gentle, but are you completely safe?
Not entirely. I'm highly flammable, and when exposed to air and light for too long, I can form explosive peroxides. That's why I'm stored in a tightly sealed, dark container. Even something peaceful can turn dangerous if forgotten.
So, if you could leave one message for those who study or use you, what would it be?
That silence doesn't mean weakness. Even the lightest touch can change something deeply. I may disappear quickly, but I always leave something dissolved behind.
For a brief moment, they stepped out of formulas and into our world. Truly, chemistry is alive if only we choose to see it.